All right, electricians, terminations are the reason we have a job. Terminations are so incredibly important that we argue about them everywhere on the internet. So let's talk about terminations. All right, so I am here to tell you that there's a lot of debating in the community about which things to use. Should we use wire nuts? Should we use these lever connectors? Should we use like pushing connectors? Should we be bending hooks on receptacles, or should we be backstabbing, right? Like there's all of this divisive opinions out there about how we do our jobs. But at the end of the day, the real important thing remains that problems happen at terminations, right? It's because we twisted some wires together and they came loose, or there's some like moisture that corroded something and oxidized a joint. So it stopped conducting electricity, or there was too much current flowing through and there was a problem with a connection and now it burned up, or it caused heating and the insulation burned off the conductor. We don't have problems in the middles of wire, right? There's nothing going on here. But at the ends of wires where we hook things up, that's always where the problem is. So our jobs as electricians, sure, we have to make sure that we're protecting the wire, making sure that we've sized the right wire, and the terminations. Those are kind of the three things electricians can't mess up. You can mess up a lot of other things, but generally these are the biggest, most important things. So let's talk about some connections. The first and foremost is obviously the wire nut, right? We've been using wire nuts since the 20s. The reason that electricians in America are so like wire nut happy and all about our wire nuts and hate everything else is because it's all we've ever known. So you might be on this whole like,
wire nuts are the best thing, you should only use those, don't use other like push-in or stab-in, whatever.
Because this is what your granddad, when he was an electrician's granddad, who was also an electrician, who had a master electrician, who also had another master electrician. This is what we've used, and that's why you like it. And I promise you that's the case. Most of the electricians out there are not taking the time to do research and testing and UL listings and all of this stuff to figure out why a material is good. We just use what we've been using. We use the same tools that we've been using. So the wire nut is probably the dumbest piece of equipment that we have to outthink how to use correctly when there's a lot of other better methods out there. So the wire nut is still a really great thing. There's a debate that exists whether or not you should be pre-twisting your joints or whether you should just be slapping two wires together like this and just do this. To me, this is the least secure way to use a wire nut, because now you've made the wire nut be the mechanical connection for the joint. And if you take it off, then you've lost mechanical connection. So I think having a secure mechanical connection on any kind of termination that you do should supersede any other kinds of things that you do to that termination. So for me, I am on the side of the pre-twist. Write your comments below. I'm sure you've got opinions, but it's okay. I pre-twist, right? I make sure that I have a good, strong mechanical connection so that it's not dependent on a wire nut to hold anything in place. Then when I put my wire nut on, the wire nut's really just there for insulation. It's to make sure that the copper inside doesn't touch anything else, but it also puts a little bit of extra on the termination. But if I take this off, I still have a strong mechanical termination. And I think to be professionals, you always have to seek like, what is the best method, right? A lot of us get into these patterns of just doing stuff because we've been doing stuff. But there's a sort of echelon of electrician where I think they start questioning their methods, and it's usually trying to obtain some sort of mastery in a subject. You evaluate your ways and realize the flaws in your ways, and you try to do things differently, which is why the pre-twist thing is a thing. I'm not saying the pre-twisting is better than other people. I'm just saying for me, it is of my opinion and many, many other electricians that having a strong mechanical connection is the best method. It's just, if you don't have a strong connection holding something in place, then any environmental factors that come along that might change the state of it can change the entire circuit to not work anymore. And then you're hunting through walls and attics. And so to me, it is a better method to make sure you have solid mechanical connection in every termination that you do. And for me, that's the pre-twist. Now let's talk about a couple of others. We've got the Polaris tap. Polaris taps, some people call them IPLDs. There's a whole bunch of different part numbers as to what an IPLD actually is. But this is a connection that has pros and cons, just like every one of these. They all have some things that are great about them and some things that just suck, okay? So we need to be honest about that. There's not one that's superior. So with these, one of the things that sucks is like these things fall off all the time in gutters. You know, if you are being stupid and working on something that's live and you don't have hot gloves and you like touch something in here that's conductive, right? So you can shock yourself, or it can like, you know, something can touch it, another wire or anything, and it can short out. So it's just not a great method. But these things as devices are really, really great devices. They put a lot of leverage down on a termination. So if I don't have Allen wrench in here, but I can use this screwdriver and it works. So we loosen up the connection, we tighten the connection. When you're using Polaris taps, you always have to make sure that whatever amount of wire that you strip out when you put in actually seats in there fully. So I see this a lot where people don't push the wire all the way forward enough, and so they don't get a good enough connection, and you can actually pull this thing loose. Second thing is they don't torque them to manufacturer's specs. So when they tighten something, they'll either over tighten or they'll under tighten. And again, these things will pull out of here. And a lot of times you're talking a huge amount of available fault current because you have large conductors in these. And the other thing that I see with these is people pushing them too far in and they didn't strip enough of the end of the wire out. So what this actual stud in there is biting down on is the insulation that you should have stripped off. So making sure that you strip out enough of the insulation is really, really important, but making sure it's biting down on only conductor is massively important. What I like about these connections is that not only is the actual plug, the thing that you're screwing in, smashing down the wire, but the entire inside of this is conductive. So it's kind of filling an entire space with conductor. So it's just a really good way to terminate conductors. And it's something that you don't see on a lot of other terminations. Most of these terminations that you'll see here is like inside of this relay or this contactor, you just got a screw that screws down. And if it's a solid conductor, you only have the surface area of the top and the bottom when that's pushing together, touching that wire. So you don't have the full conductivity of the entire conductor that's making a contact with a termination. Does that matter? Well, it's just something to think about. Like, what are the methods that you use and why do you use them? So for something like this, some people might even say, okay, well, I want to use a crimped on connection, like one of these rings or one of these spades. There's a whole bunch of different crimp on connections, but it's a different way to achieve a really strong, good crimp. Don't over crimp, don't under crimp, but it gives you a really strong crimp, which is a good connection. And then it seats up with the termination with this blade. So this is another really great method for terminating things, but also does come with its flaws, right? Like these things, sometimes you don't get it crimped right and oh, that just pulled out. So I crimped that and I thought that I had a good crimp and it turns out it really wasn't. So I didn't do my job as an electrician to make sure that this was crimped fully and had full mechanical strength before adhering it to the wiring method. So think about your terminations that you're putting together and whether or not the method that you're using to do it is the best method available. So another way that we often terminate things is we've got the hook, right? Many of us are familiar with the hook. Most receptacles and switches nowadays have a screw terminal on them. We bend a hook and we wrap this hook around a screw. And then when we tighten it, we've got the entire 360 degrees of that termination fully seating with the bottom of the screw and the plate underneath. We're pinching the entire conductor. It is a very solid connection. You're not going to have that come off. The only problems that I see with screw-on terminations are people don't screw them tight enough or they bend their hooks in the wrong direction. So this thing screws in righty-tighty, right? Clockwise. You want to bend a clockwise hook and put that on there. So as you're tightening the screw, the conductors are actually tightening around that screw as well, but very, very solid method. Now, there is the stab ends, right? All of us seem to hate the stab ends because back when receptacles were made back in, like the 60s, 70s, there weren't very good listing standards for how a receptacle should be built. I think we're kind of all on the same page that like, just don't do it. But I'm here to challenge that it's not as much of a problem. Modern day receptacles are constructed differently than old school receptacles. So when you push something in, it's still out of the options that you have on the receptacle. The best wiring method on the receptacle is the screw terminal, right? It's just a good surface area, solid connection. If that thing is mechanically bolted in place, it's not going anywhere. And I would argue that a push-in is not as good. But this push-in connection in here would not exist if there was not a standard that allowed it to exist and that products had to actually rigorously test whether or not this is acceptable. So it's not necessarily that the stab-in method is a bad method, it's that the materials back then were not made to the same kind of standards, right? Like we have Federal Pacific, these guys, we've got Challenger, we've got Pushmatic, we've got Wadsworth, we've got all these brands, Zinsco, that over time, they were making things that were not very good, and the standards around them, they were either lying and saying they were adhering to the standards, or they weren't really adhering to them. But the whole having product listings and standards was way weaker in those days than it is today. Today's product standards that we put out and the listing that we have to, the testing that has to be done on a product before it is able to get a stamp and actually be mass produced for the public is really strong. Like there's a lot they have to do. So nowadays, when you have a UL listing on a product, it means it's very, very tested and very well thought about, and a standard has been community written for how this should be designed and function and what kind of tests it needs to undergo to make sure that it's a solid product. So we've got the push-in thing, right? Push-in is not a bad method, right? We've got these little push-in connectors that, boom, you push them in, they're solid. I use these things all day long in ballasts. If I'm up in like a Home Depot or Walmart or something like that, and I've got 100 rows of like 100 fluorescent fixtures, just lines and rows of them, I'm not gonna sit here and take wire nuts and like cut the red, red, blue, blue, yellow, yellow, black, white, and on every single one of them, strip them out and like sit and twist and make all these wire nuts. Dude, it's gonna take me all day to do that. So what I do is I take all my ballasts, I get a shopping cart, and I lay all of them across the shopping cart, and I take all the ends and I put the push-on connectors all the way through every single one of them. So I've got all of these finished pre-wired ballasts with connectors on them already, and then I grab one, go and pull one down, slap the other one up, and then I just plug the wires in and I'm out. Like it's so much faster. So there's a reason why you might use a certain wiring method, and it might be speed. So there's different reasons for every single one of these as to why we would want to consider using them. And that's not to say, again, every single one of these has flaws. Like when you use one of these push-ins, you push it in, it should hold, right? Pretty easy to get off though. So you just twist them a little bit and they come off. So it's not a mechanically awesome, best of the best securement, but it is really easy to get them out and get them in, and they do provide a really good hold. So I tend to use these with smaller wires. If I'm going to do something in a ballast, or if I've got, again, like a recessed can or something where there's a small termination, and I don't want all the bulkiness of 3 of these crazy things in there, these just smush into place much easier. I don't have any problems with them. But again, it's on you, the electrician, to make sure that you have a solid connection. So a lot of people will just push these things in, they won't strip enough conductor out, and they'll smash it up in there. And then the insulation is the thing that's getting bit onto. So there's actually no conduction happening because it's the insulation that's being grabbed. So it comes back to you, the electrician, making sure that you're providing a solid termination. Now, I will say there's other connections that I'm not as much of a fan of. They're not bad. They're obviously UL listed. They're tested rigorously, and it's okay to do them. But any of these like GFCI receptacles that you see where there's a plate. So this thing has a little plate in here. There's a screw, and some people like say, screw the plate. I'm just gonna let the plate sit down and I'm gonna bend a hook around the screw. But you don't have to do that. Like these plates are here because they are tested to work. So you put that little bit of wire in there. This is a good termination, right? There's a plate under there. It's still pretty solid. I would say I could twist this probably, but a lot of people feel insecure about the plates, right? Because it's just some kind of a plate touching down on a round thing, and it's like pushing it in place, and it's not smashing it. It's not creating like a good dip where all the material's spreading out in the termination. It doesn't have as much surface area. If you wrapped a screw, you're gonna get all the surface area from the top and the bottom of that whole hook. Whereas this thing, you've just got this little tiny plate in here. So a lot of people don't like those, but it's okay. Again, it's tested rigorously, and I'm serious, I'm pulling with everything I got and I can't get that off. So it's okay. It's really about the surface area and the mechanical security of the termination. So like, right, this is mechanically secure. It means that there is something securing this, that it's not relying on some little inferior part to be secure. That's why, again, I'm gonna go back to this. That's why I'm good with pre-twisting, because it's mechanically secure, and I'm just adding this for a little bit of love, a little bit of, insulation. But as a wiring method, it is secure without needing help from anything else. So some other times that we use push-ins, right? We've got these little quick connects. A lot of us put these on ballasts too. So this thing, you bring your line side conductors in here, your load side conductors out here. And if you want to disconnect the ballast, you got a quick connect that comes apart. But these things, it's just pushing wire inside of them, you know, boom. And I can work this out. I can sit and twist it out. It's not as secure, but it's something that we use all day long and there's no problems with it. Now, the next thing to talk about are these lever nuts. So a lot of people just haven't had experience with these because some of the suppliers in their area might not carry them or they might not find them at Home Depot, but these are largely used in the UK, whereas they don't use wire nuts like we use. And we use wire nuts, and so we say, oh, don't use any of those, they're silly. But I will challenge that these things are really dope. So with this is a dummy piece of material, right? I have to outthink and outskill this piece of material to ensure that it doesn't fail me. So if I'm making a connection, I have to spend time and pre-twist or not pre-twist, whatever. But in order to use it, I have to make sure my side is good. And then what happens if all of a sudden you're like, oh crap, I got to add this stranded wire in there. Well, you got to know from experience that you don't just put the stranded wire in like that. You got to bring it out in front and put it in front. So it just kind of like mashes it all up in there, right? So I have to outthink and outskill this dummy product. This is an engineered, precise product. So when I put conductors in here, I just pull these little levers, completely opens up. I can put a solid in there. I can put a stranded in there. I just lock it back down and it is a mechanical locking in place. So you have a secure mechanical connection inside of it. The other great thing is that they're see-through, right? So I can like look at the backs of these and I can actually see like, okay, that termination looks good. There's no brown, there's no, you know, I've actually got good conductivity. There's even a port inside of these things. So I can take a multimeter and I can stick this down in there without having to change the state of the joint. I can test this thing while the conductors are in it. So again, dummy material. A lot of times for these, you actually have to take this wire nut off and you're like, oh no, I'm changing the state. I'm changing the state of the circuit because I'm messing with it. And once you get it apart, you're like, crap, I don't know if that was actually touching or not touching because I had to change the state of it just to be able to use this wiring method. With these, you don't have to change anything. So it's really great because in Europe, their standards for things are a little bit more precision engineered. We're cowboys in the US still, you know, like we just kind of do whatever works. But that's the thing. I'm not calling these better and that you're supposed to change everything you're doing and wire every one of your houses with these. I'm just saying that there are really great use cases for these and people, you know, crap on like using any kind of push-in or lever nut type of a product because they don't have experience with it and they don't understand the use case for it. So in something like this, like you're gonna save a lot of space, right? If you have some kind of a small junction box or something, these things are killer. If you want speed and you wanna just fly through a job, these things are so fast. You just boom, boom, put the wire in, snap it down. If you wanna take one out, pull it up, snap it out. You're not gonna change the state of anything that you're doing. You don't have to untwist anything that's already been twisted together. So it's a solid wiring method. Now on these guys right here, these are the WAGO 221. So thank you WAGO for sending these to me. And I know you guys probably keep hearing me say WAGO after I've said WAGO and many other videos in the past. It's actually WAGO, straight from the horse's mouth. It's actually WAGO because it's German. But WAGO is how you say it. Anyways, they sent me a whole bunch of these 221s. I think they're rad. There's a whole bunch of different ones that I didn't actually know they existed. Most of the time I was looking at like 2-port, 3-port, 4-port, or 2-barrel, 3-barrel, 4 barrels, what we say out in the field. But there's a butt splice one, right? Where you get take 2 conductors, go end to end, boom, put them together. I've got one right here. This is so strong. It actually grips more the harder that you pull onto it. So it's a very, very solid termination and I cannot rip it apart. So I didn't even know that they made something like this where you could do a butt splice where you have levers where you can actually pull each one of the things out. I just think that's really cool. Then they also have like, you know, the 2s, the 3s, they've got some in here that are 5, and then they've got a side-by-side 5 and 5 where they've got up to 10. They have some of these that you can do direct burial with. So there's like this little clamp-on jacket that goes around it and makes it secure for direct burial. There's some for hazardous locations. So there's on their website, we're going to put a link in the description below, but you can check out all the different use cases and the different kinds of WAGOs that exist. They're really great. I think you guys should consider using them. A master electrician friend of mine actually told me this. This is something I'd not thought about before. But when you have one of these lever nut devices, when you put conductors in there, if you're going to fold it in somewhere, making sure that these things don't come unhinged, because then the wire is loose in there is really important. So some people will wrap some tape around them, but just whatever you're doing as a way to make sure that this is safeguarded so these don't fold up, just pay attention to it at least. So if you're folding this into a box, make sure before you walk away that you make sure everything's pushed down. These are really strongly held, but like, dude, some of us gorilla Hulk, wires into a box. So just make sure none of these pop open on you. When you put a stranded wire into something, these little strands, we call them widow makers. If one little strand comes out and you put a wire nut in and it's all janky like this, that will still short out. That's the same thing as having all of them. It's just a smaller amount. So you're probably gonna see a massive amount of current trying to go through a really little space. But making sure that when you're dealing with stranded wires, that you get all of them combed down the way that they're supposed to be. And I even go as far when I'm dealing with stranded as to pre-twist my stranded. So I get that question a lot when I talk about this whole like pre-twist versus not pre-twist. It's like, yeah, but do you do it with your strandeds? Yes, I do. I will pull these out and I will sit here and twist. And you got to just manage and groom all those conductors. But for me, again, my whole reasoning here in talking to you guys about all this stuff is this is a solid mechanical connection, right? It's hard to pull that out of there. It's a little bit easier with stranded to pull this out than it would be with solid. So solid, the pre-twist thing is even a better method because when those things wrap around each other, like it's going to be really difficult because they're solid, right? They're solid pieces of metal that are grabbing onto each other. So my point with all of this stuff is that your job as an electrician is to make sure you have secure connections, whether you're CAD welding a ground rod at a light pole, for some reason having to do that, which I've had to do just for an inspector to be happy, or you're twisting wire nuts or you're not twisting them and you're just slapping them on and going, whether you're putting something on like a wire nut and you are tightening the ever living crap out of it and then even grabbing your lineman pliers and putting more on it, you can definitely over tighten a wire nut and it starts to deform on the inside. And then you can use the wrong wire nuts. You can not use the black high temp wire nuts up in an HID fixture and just use one of these regular ones and then they melt or they get brittle and dry out and they crack, right? So like every one of these things has something about it that kind of sucks, but they also have something about them that's really awesome. And so to say that one of them shouldn't be used or should be used, it's up to you as the electrician to make sure that whatever you're installing, your only job every day is to make sure your terminations are solid, right? Be informed about why you use the things that you use and how you use them. There's little things, like a lot of you might not know that every wire nut you use is listed for a certain number of conductors and certain sizes of conductors. You might have one of these that you can put 4 number 12s in and you're over here trying to cram 8 of them and you think it's okay, but you're violating code. You're going against manufacturer instructions and you're violating the listing of the material, what it's actually used for. You might not realize that there's like 50 different kinds of wire nuts. You might not realize that some of these WAGOs have, like green ones there's eco-friendly material that's put it with these. Some of them are for direct burial. Like there's a lot of, hazardous environments. There's a lot of like different materials that we have to know about so that we know, like the environment that we're in, the environmental factors that are going to wear and degrade on material as to why we would select one over the other. And it's not as simple as just grab a bunch of wire nuts and let's do all of this. There's instances where like you're doing a motor, you open up a pecker head and you're doing a motor. It might be better because of the vibration of that motor not to use wire nuts and to use something that's like one of these crimp-on ring terminations or something like that. So there's so much more to the termination thing than the average person thinks about. So I'm just here to encourage you guys to learn a little bit more before having biases and opinions about things. Understand that everything has thumbs up and thumbs down about it, but there is specific use cases where some things are going to probably be a better method than others. And it's up to you as an electrician to grow and mature and learn more to make that determination yourself. So hope you guys learned something. Love you crazy people. I'll see you in the next one.